Video number 109 from MythoReligio series, Book 4. Dragons or Dinosaurs, Part 4. Epilogue 1. How old is the Earth? Dear fellow truth seekers, this video is the first part of the epilogue of MythoReligio book number 4, where I discuss about unanswered mysteries on the history of our planet. Kindly watch playlist MythoReligio Book 4 for the complete topics at hand. In my earlier videos number 103 until 105 in the Forbidden Archaeology playlist, I have shared information about several ancient artifacts that seem to prove that civilized humans have existed much longer than what historians have been telling us. According to the theory of evolution, modern human, i.e. Homo sapiens, only appeared in Africa around 200,000 or maximum 300,000 years ago. And yet, we actually found man-made artifacts that are already millions or even billions years old. But they have been ignored by mainstream academics because they do not fit with the conventional historical timeline. Then, in the later videos number 106 until 108, I have shared some possible proofs that what we call dinosaurs today might be the same creature that our ancestors called dragons in the past. The possible proofs that I have shared with you are in the form of ancient and not so ancient artifacts from around the world, i.e. Babylon, Thrace, Sumeria, China, Thailand, America, France, Nepal, Mexico, and Indonesia, that are strikingly similar to known species of dinosaurs, such as Mastospondylus, Synthosaurus, Apatosaurus or Brontosaurus, Brachylophosaurus, Sauropods, Saurolophus, Pterosaurs, Decadontosaurus, Ceratopsius, and Parasaurolophus. The fact that our ancestors could make artifacts that are eerily similar to various known species of dinosaurs is of course surprising, because according to conventional paleontologists, all dinosaurs already extinct from the Earth at circa 65 million years ago. I found it strange how this fact has been almost totally ignored by the scientific world, although the original comparison itself was at first made by a real scientist, i.e. Robert Caldaway, a German architect and archaeologist. The images that I have shared with you in the aforementioned videos are actually found by some Christian researchers who intended to prove the validity of the Bible that mentions about dragons in some of the verses. And these researchers believe that the Earth is only circa 6,000 years old based on the calculation from the biblical verses. Yes, it is true that none of the artifacts are older than 6,000 years old. However, just because these artifacts are younger than 6,000 years old, do not necessarily mean that the creatures themselves, i.e. these dragons or dinosaurs, are only extinct less than 6,000 years ago. The artists could have copied them from earlier artifacts that had been passed down from generations to generations, right? The creatures themselves might already been extinct by the time the artifacts are being made. The same way as the fact that we have drawings of dinosaurs made in modern days does not mean that dinosaurs still exist today. In order to find out which timeline is correct, let's analyze whether the Earth is young, i.e. circa 6,000 years old, or old, i.e. 5.54 billion years old according to conventional science. So, how did scientists come up with that number? The main source of the following information is a simplified form of an article entitled How Old is Earth and How Do We Know? By Robert H. Hazen. There are numerous of independent evidence that may be used to determine the age of the Earth. Here we will only use three methods. 1. Annual layerings. 2. Geologic rates. And 3. Radiometric dating. 1. Annual layerings. The easiest example to understand annual layerings is by looking at annual tree layerings, or tree rings. Each year of a tree's life is marked by a distinctive ring, as growth increases in spring and slows the following winter. The oldest trees on Earth are a few thousand years old. The oldest tree ring we have found so far is dated at 26,000 years. This number is made by comparing living trees with buried logs of increasing age. Sedimentary rocks too can display annual layerings or varves that result from seasonal differences in sediment deposition. The most dramatic varve deposits, such as a meticulously documented 13,527-year sequence in glacial lakes in Sweden, occur as thin alternating light and dark layers representing coarser grained spring sediments and finer winter sediments respectively. Ancient varve deposits sometimes preserve much longer time spans. The finely laminated Green River Shale in Wyoming features continuous vertical sections with more than 1 million varves. The oldest annual layers are extracted from ice cores whose laminae arise from seasonal variations in snowfall. A 2-meter ice core from East Antarctica reveals 160,000 annual layers of accumulation, year by year, snow layer by snow layer. And those annual layers rest atop another 2,000 meters of ice which sit on vastly older rocks. Similar ages of ice cores comprise Greenland's thick glacial deposits. A sediment frozen under 1.4 kilometers of ice contains well-preserved fossil plants and biomolecules sourced from at least 2 ice-free warm periods in the past few million years. Meaning, the Earth must be much older than that. But how old? 2. Geologic rates. The slow, unstoppable changes of Earth's surface can also be used as an approximate method of calculating the age of the Earth. We will use 3 geological areas as examples. To calculate it, we can apply 3 simple calculations. A. Hawaiian Islands. The Hawaiian Islands are a chain of volcanoes, each formed from layer after layer of lava. The tallest volcano is Mauna Kea. First, how old is the Big Island of Hawaii? The massive Hawaiian Islands rose from the Pacific as volcanoes periodically added layers of lava. From modern-day eruptions, we know that active volcanoes grow by perhaps a meter every century. The highest point on the Big Island of Hawaii is Mauna Kea at 4,205 meters above sea level. However, the volcano rises approximately 10,200 meters above the ocean floor. So a rough calculation gives its age circa 100 years per meter times 10,200 meters equals to circa 1,200,000 years. B. Atlantic Ocean. Second, we can do a similar calculation to date the Atlantic Ocean, which is about 3,700 kilometers wide and grows wider every year. The near-perfect fit for the east coast of South America with the west coast of Africa provided key evidence for plate tectonics. The idea that Earth's crust is broken into about a dozen thin brittle plates that shift positions in response to convection in Earth's deep interior. These continents were once joined into the supercontinent Pangaea. The Atlantic Ocean formed when Pangaea split down the middle and formed a divergent boundary now marked by the Mid-Atlantic Ridge. New crust forms along the ridge as Europe and Africa move away from the Americas. Exacting satellite measurements over the past 2 decades reveal an average spreading rate of 2.5 centimeters per year. So, the approximate age of the Atlantic is easily estimated as 3,700 kilometers times 100,000 centimeters per kilometers divided by 2.5 centimeters per year equals to 148 million years. The Appalachian Mountains. The third simple calculation reveals even longer time spans. The Appalachian Mountains are now gently rounded and relatively low, mostly below 3,000 meters high. But geological evidence reveals that they once were the grandest mountain chain on Earth, rivaling the Himalayas in ruggedness and height, with some peaks at more than 10,000 meters. Ever so gradually, erosion has worn the Appalachians down to their present state. But how long might that process take? For the sake of rough estimate, consider a mountain as a rectangular block about 5 kilometers high, 4 kilometers long, and 4 kilometers wide. That's about 2.5 miles on a side. The volume of this impressive mountain is thus 5 kilometer times 4 kilometer times 4 kilometer equals to 80 cubic kilometer equals to 80 billion cubic meters. Now imagine a stream that flows down the side of this mountain. Mountain streams carry silt and sand downwards, a key factor in erosion. You'll probably also find coarse gravel and even a few boulders in the stream, the result of occasional flash floods that follow heavy rains. All of these sediments came from higher up the mountain, which is constantly being eroded away. To estimate how long a mountain might survive against erosion, consider a mountain with 6 principal streams. A typical stream might carry an average of 1/10 of a cubic meter of rock and soil, a few shovels full per day of the mountain, though the actual amount would vary considerably from day to day. Over a period of a year, the 6 streams might thus remove 6 streams times circa 0.1 cubic meter per stream day times 365 days per year, equals to circa 219 cubic meter per year. That means every year, on the order of 220 cubic meters of material, or about 20 dump trucks full of rock and soil, might be removed from a mountain by normal stream erosion. If the mountain streams remove about 220 cubic meters per year, then the lifetime of the mountain can be estimated as the total volume of the mountain divided by the volume lost each year. 80 billion cubic meters divided by 220 cubic meters per year equals to roughly 364 million years. This estimate is certainly rough and not directly applicable to any specific mountain. So now we got a much older age, but nevertheless, a few 100 million years is but a small fraction of a few billion years. How did scientists come up with the age of 4.54 billion years old? 3. Radiometric dating. Radiometric dating is a way to find out how old something is. Radioactivity is simply when a very small particles in objects emit energy or smaller particles. Isotopes are members of a family of an element that all have the same number of protons but different numbers of neutrons. For example, hydrogen and its 2 naturally occurring isotopes, deuterium and tritium. All 3 have the same number of protons, labeled P positive, but different numbers of neutrons, labeled N. Now, radiometric dating is a method that compares the amount of a naturally occurring radioactive isotope and its decay products. Trace amounts of isotopes of radioactive elements including carbon-14, uranium-238, and dozens of others are all around us, in rocks, in water, and in the air. These isotopes are unstable, so they gradually break apart or decay. Radiometric dating works because radioactive elements decay in predictable fashion like the regular ticking of a clock. Here's how it works. If you have a collection of 1 million atoms of a radioactive isotope, half of them will decay over a span of time called the half-life. Uranium-238, for example, has a half-life of 4.468 billion years. So if you start with 1 million atoms and come back in 4.468 billion years, you will only find about 500,000 atoms of uranium-238 remaining. The rest of the uranium will have decayed to 500,000 atoms of other elements, ultimately to stable, i.e. non-radioactive atoms of lead-206. Wait another 4.468 billion years and only about 250,000 atoms of uranium will remain. The best known radiometric dating method involves the isotope carbon-14, the half-life of 5,730 years. Every living organism takes in carbon during its lifetime. At this moment, your body is taking the carbon in your food and converting it to tissue, and the same is true of all other animals. Plants are taking in carbon dioxide from the air and turning it into roots, stems, and leaves. Most of this carbon, about 99%, is in the form of stable, meaning non-radioactive carbon-12, while perhaps 1% is the slightly heavier stable carbon-13. But a certain small percentage of the carbon in your body and every other living thing, no more than one carbon atom in every trillion, is in the form of radioactive carbon-14. As long as an organism is alive, the carbon-14 in its tissues is constantly renewed in the same small part per trillion proportion that is found in the general environment. All of the isotopes of carbon behave the same way chemically, so the proportions of carbon isotopes in a living tissue will be nearly the same everywhere, for all living things. When an organism dies, however, it stops taking in carbon of any form. From the time of death, therefore, the carbon-14 in the tissues is no longer replenished. Like a ticking clock, carbon-14 atoms transmute by radioactive decay to nitrogen-14, atom by atom, to form an ever smaller percentage of the total carbon. Scientists can thus determine the approximate age of a piece of wood, hair, bone, or other object by carefully measuring the fraction of carbon-14 that remains and comparing it to the amount of carbon-14 that we assume was in that material when it was alive. Carbon-14, or radiocarbon dating, as the technique is called, is accurate up to 50,000 years, or with special sample preparation methods, the range can be extended up to 75,000 years. Potassium-argon dating is a dating technique based on the radioactive decay of potassium, or 40K, to argon, or 40Ar. This potassium isotope has a half-life of circa 1.3 billion years, and the minimum age limit for this dating method is about 250,000 years. This dating method is based upon the decay of radioactive potassium-40 to radioactive argon-40 in minerals and rock. Thus, the ratio of argon-40 and potassium-40 in a mineral or rock is a measure of the age of the sample. The oldest known rocks, including basalt and other igneous formations, solidified from incandescent red-hot melts. These durable samples from the Moon and the meteorites are typically poor in potassium, but fortunately, they incorporate small amounts of uranium-238 and other radioactive isotopes. As soon as these molten rocks cool and harden, their radioactive elements are locked into place and begin to decay. The most ancient of these samples are several types of meteorites in which slightly more than half of the original uranium has decayed to lead. These primordial space rocks, the leftovers from the formation of Earth and other planets, yield an age of about 4.56 billion years. The oldest known moon rocks, at about 4.46 billion years, also record these earliest formative events. Earth must have formed at about the same time, but our restless planet's original surface has now eroded away. Only a few uranium-rich sand-sized grains of the hardy mineral zircon, some as old as 4.4 billion years, survive. Overwhelming observational evidence confirms that Earth history is the story of the co-evolving geospheres and biospheres. Life has changed continuously over the course of Earth history. Therefore, based on the isotopic analysis of many meteorites, as well as soil and rock samples from Moon, the age of the Earth is now concluded as 4.54 billion years old. Now, is radiometric dating really accurate? As of today, 2023, an error margin of 2 until 5% has been achieved on some rock dating, i.e. on younger Mesozoic rocks. This can be between 2 million years to 2.5 billion years. However, the age of the Earth remains old and still in the billions of years. Such a conclusion is at odds with the doctrine of many Christian fundamentalists who believe in the literal biblical chronology of a universe no more than about 6,000 years old. This age of 6,000 years old is very hard to defend though. Even if we push the number to 10,000 years old, it is still too minuscule in comparison to billions, millions, or even 100,000 years. Even if we compare 10,000 years with a 3-ring dating system, i.e. the oldest is 26,000 years, it is still not close. And much further still if we compare it with the geologic rates, which goes to hundreds of million years. So I would say it is safe to conclude that the Earth is old. How did the Bible get it wrong if it is truly from God? Which I believe it is. The strange thing is that the Holy Scripture of the Hindus, i.e. the Veda, indicates the age of the Earth that is close to the scientific one, that is 4.32 billion years old. Could the Veda have been revealed by God then? Yes, I believe it is too. Dear fellow truth seekers, in my next video I will continue with the second part of this epilogue, and after that I will start sharing with you my research on how religions, all religions, become they are today. For now, I thank you for watching and hope to see you on my next video.